This is Honors GL, Chapter 8, Section 5. Alright, so uh, up to this point, in terms of our quadrilaterals, we've been dealing with the parallelogram family, which is opposite sides being both parallel and congruent. Diagonals are bisect each other. Then we went specifically to different types of parallelograms. We did rhombus, which was a parallelogram with 4 congruent sides. We did rectangle, which is a parallelogram with 4 right angles. And then we did square, which is a parallelogram that contains both the characteristics of a rhombus and a square, which is 90-degree angles and 4 congruent sides. And now we're going to do the last 2 types of quadrilaterals, and those are trapezoids and kites. And trapezoid is a different from parallelograms in that they only have one pair and only one pair of parallel sides, so that are opposite, as opposed to both pairs. So when we talk about a trapezoid, it is a quadrilateral with exactly one pair of parallel sides. Okay, one pair. So when we talk about a trapezoid, in this case, BC is going to be parallel to AD. Right? Those are my parallel sides. The 2 parallel sides, they're called the base. The 2 opposite parallel sides are called the base. And the other side that's not parallel, that's not the base, they're called the legs. Yeah. So BC and AD, they would be the base. And AB and DC will be the legs. And remember, the base are always the 2 parallel sides within a trapezoid. Alright, so in this example, we have a coordinate plane, and they did the slopes of all 4 sides, and they found that RS is parallel to TO. So this is a trapezoid. RO is not parallel to ST. But then they changed it in the example here, and they said, okay, what if point S is 4, 5? So this guy goes from 2, 4 to 4, 5. So R is 0, 3. S is 4, 5. T is 4, 2, and O is the origin. Okay. So what we're going to do is just take the slope of all four sides now that we have those coordinates. So let's do R to S. So slope of RS, right, that's rise over 1, which is x1, or y2 minus y1 over x2 minus x1. So I'm going to do 5 minus 3, which is 2, over 4, and that equals 1/2. So the slope of RS is 1/2. Let's do the slope of RO. So R and O. Okay. R and O. So 3 minus 0 over 0 minus 0. That's undefined. So we're dealing with a vertical line. And the slope of, let's do TO. There's TO. That's 2 over 4, which equals 1/2. So we have a pair of parallel sides right here with RS and TO. So we have at least a trapezoid. So let's see what we have here. So that leaves us with ST. On ST we have 3 over 0, which is undefined, meaning we have another vertical line. So we have two pairs of parallel sides. So since we have two pairs of parallel sides, when we change this guy, RS or ORST is a parallelogram. Why? Because we got opposite sides that are parallel. Definition. Parallelogram. Which of the interior angles of the quadrilateral are supplementary? So if I was to draw out the trapezoid, as one pair of parallel sides cut by two transversals, this would be consecutive interior angles, right? And we know that consecutive interior angles are supplementary. So O R S and T. Yep. We know that these guys are supplementary, and then these guys would also be supplementary. So angle O plus the measurement of angle R, they would be supplementary. And angle T plus angle S would also be supplementary, because those are the transversals that cut across the two parallel lines. And then you just have your trapezoid. So, since there's only one pair of parallel sides, we only have one consecutive side, one pair of consecutive sides that are supplementing. All right, which leads us to our next type of trapezoid, and that's the isosceles trapezoid. When we talk about isosceles trapezoid, an isosceles trapezoid is a trapezoid where we have where the legs are parallel. Two legs are parallel. So isosceles trapezoid a trapezoid where the legs are congruent. Okay, trapezoid where legs are congruent. So that leads us to various theorems. First theorem, theorem 814.